Euclid's proposition 1-8 is so ridiculously simple, I didn't even bother to draw it on graph paper. Alright? Now, what he's basically saying is this. Alright, if you have a triangle in which you have two sides that are equal to two sides on another triangle, because now we have triangle ABC and we have triangle DEF. Alright? And what he's saying is that if AB equals DE and AC equals DF and BC equals EF, then you're going to have all the angles in this triangle equal to all the angles of this triangle. And so what he's saying basically is this, and I'll just read this to you real quick. I think you can pretty much figure out what he's trying to do here. Alright. He's saying that, like I said before, AB equals DE, okay, and AC equals DF. DF right there. And he's also saying BC equals EF. We got that part established so far. Okay, then he goes on to say the angle BAC, right there, is equal to angle EDF. Then here's E, D, and F. EDF. Alright? So what he does is he takes a triangle ABC and he places it right on top of triangle DEF. Alright? And he places point B on point E, and he places point C on point F, because we've already established that BC is equal to EF. And then he says that BA and ED, right there, will also coincide with AC and DF, right there and there. Okay, now, he goes on to say that if AB doesn't land directly on top of DE, and AC does not land directly on DF, then what's going to happen is that they're going to find another point, which is G. And as we established in Proposition 1-7, you can't have two lines that are equal in length drop on two different points at the same time. Because if you do, you start having angles that are not equal suddenly becoming equal, and you can't have that. That's absurd. So therefore, if you were to place triangle ABC on top of triangle DEF, all the sides here, AB would equal to DE, AC would equal DF, and BC, of course, would equal EF, and all these angles, BAC, EDF, they'd be equal. Angle ABC would be equal to angle DEF, and of course ACB would be equal to DFE. Okay, so basically these two triangles are exactly the same size, both on the sides and on the angles as well. Alright? Now that doesn't mean they're equilateral triangles, doesn't mean they're isosceles or anything like that. It just means that this triangle is exactly the same size as this triangle right here. Because if it wasn't, you'd see this absurdity, and this absurdity doesn't exist, so therefore, boom. Anyway, like I said, this is ridiculously simple. You could have derived this from 1-7, but he went ahead and said it anyway, so therefore. Alright, that basically covers Proposition 1-8 in a nutshell. If you have any questions, you can go ahead and email me, or you can comment me, or whatever. I will talk about more in a future video, so stay tuned.